Hello students, we had already discussed on non-conventional machining process and milling machine and milling process. Today we will discuss on new topic gear manufacturing. In this topic we will discuss on introduction to gear, type of gear, advantages and disadvantages of gear drive, selection of gear material and gear manufacturing method. Introduction. A gear is an important machine element which is used for transmission of power or motion or both from one shaft to other. It is normally a round blank carrying projection or teeth along its periphery which enable a positive drive. Gears are widely used in various mechanisms and devices to transmit power and motion positively between parallel, intersection, or non-intersection or non-parallel shafts without change in direction of rotation, with change in direction of rotation, without change of speed, with change in speed at any desired ratio. Of, Often some gearing system is also used to transform rotary motion into linear motion and vice versa. In this presentation, we discuss on different types of gear. First, spur gear. Spur gear are the most common, most widely used and least expensive gear. A spur gear is a wheel with teeth cut parallel with the axis of rotation. The teeth are straight. Spur gear are used to transmit motion from one shaft to another shaft that is parallel to it. Spur gear are made in a great variety of size from less than 25 mm to several centimeters in diameter. Spur gear are made of steel, brass, other metal and plastics. Helical gear. A helical gear is just like a spur gear but with its teeth at an angle with the axis of rotation of the gear body. Helical gears can transmit motion from one shaft to another shaft that is parallel with it, as with spur gear, and also to another shaft that is not parallel to it. Helical gear operates more quiet and smoothly than spur gear. This is due to the fact that teeth of helical gear slide one across the other rather than hitting each other, as in spur gear. Moreover, unlike spur gear, in helical gear, several teeth of each gear are in contact at one time and thus the load is spread, resulting in greater strength than if only one tooth of each gear is in contact at a time as in spur gear. However, in helical gear, the friction, heat generated and wear is high because of sliding action of one tooth on another. Therefore, helical gear should run in oil bath as in automobile transmission. Another disadvantage with helical gearing is that helical gear exert an end thrust which must be absorbed by a thrust bearing. Herringbone gears. A right and left hand helical gear side by side from the herringbone gear. Originally, a herringbone gear consisted of two helical gears, one right-handed and other left-handed. But today, most herringbone gears are produced as a single unit on special machines which cut the teeth in two directions at one time. The herringbone style neutralizes the end thrust and makes a strong point gear. Since such gears have a greater bearing surface, they possess exponential tool strength and heavy load carrying capacity. They stand up under a continuous high speed operation better than other gears. Cutting herringbone gear is slower and more difficult, so they are most frequently used in the larger size for heavy machinery. Herringbone gear is sometimes called as a double helical gear. Worm and worm gear. Another form of gear used to connect shafts whose center line do not meet is the worm gear, which differ from all the preceding types of gear in that one element is a screw and the other is the worm gear with innerping teeth. Worm and worm gears are used when a large speed reduction ratio is wanted from one shaft to another. Ratio as high as 70 to 1 can be made in with a worm and worm gear, whereas the other type of gear cannot easily given more than about 6 to 1 in one pair. The teeth on the worm gear are helical and conform with the helix angle of the tooth on the worm. Helical tooth on the worm is a form of thread similar to an acme thread. Worm may have single, double or triple threads. One revolution of double thread worm revolves the worm gear an amount equal to two teeth on the gear and so on. The worm gear cannot turn the worm when a single thread worm is used. This type of gear mechanism is self-locking and hence is used in steering mechanism and hoisting equipments. Worm gearing is used largely for speed reduction. Bevel gear. A bevel gear is one in which the teeth are cut so that they radiate from the apex of a cone and lie on a conical surface. A set of two bevel gears is used to transmit a power from one shaft to another shaft which is not parallel to the first one. Bevel gears are available with straight, helical and spiral teeth, where smooth running is required to avoid a noise at high speed. The straight bevel gears are inferior to the spiral bevel gear. Bevel gears are more expensive to cut than spur gears. The most usual size of bevel gear are 300 mm diameter and under. Rack and pinion. A rack gear is a straight piece and has no curvature. It represents a gear of infinite radius. Teeth are cut on this flat straight piece. A rack gear, when meshed with pinion, is used to change a rotary motion to reciprocating motion or the reverse. Rack and pinion arrangement is used in feeding mechanism and for reciprocating drives. Rack gear may have either a straight or helical teeth. Rack gear are cut with equipment much the same as that used for a cutting spur or helical gear. Advantages of gear drive. They are positive and non-slip drive. They can transmit large power. Gear drive have high transmission efficiency. They can transmit motion over a small center distance of shaft. Gear can transmit motion even between non-parallel intersecting shafts. These are the most compact compared to belt and chain drive. Disadvantage of gear drive. Gear design and manufacturing is expensive. Installation is difficult. Tooth wear may occur during power transmission. Inaccuracy in gear tooth cause noise and vibration. Material used in gear manufacturing process. The various material used for the gear include a wide variety of cast iron, non-ferrous materials. Selection of gear material depends upon types of service, peripheral speed, degree of accuracy required, method of manufacturing, required dimension and weight of the drive, allowable stress, shock resistance, and wear resistance. Thank you.